Hello everybody. Well, I just shared with you in the last lecture that the very application of slope of a line is to judge whether two lines are parallel or perpendicular, and very beautifully we were able to derive two if and only if conditions for two lines to be parallel and two lines to be perpendicular. Now, two lines are parallel if and only if their slopes are equal. Fine, if and only if, and they have to be two non-vertical lines, otherwise their slopes are not defined. So what's the point in even talking about them in terms of their slopes? Secondly, we also declared that two non-vertical lines are perpendicular if and only if the product of their slopes is -1, or in other words I can say slope of one is negative reciprocal of the slope of the other, right? And that was also if and only if. So these two very important major conditions about two lines to be parallel or perpendicular was drawn in terms of or with the help of defining their behavior of the slopes. Another application of slope is there. What is it? It is to find out the angle between two lines. Another very important and beautiful article. Now see, whenever you draw two lines in a plane, either you draw them to be parallel lines or you draw them to be intersecting lines. If suppose two lines are parallel in your plane, if you draw two lines to be parallel, one is this line, other is say this line. This is line L1, this is line L2. The moment I am saying they are parallel lines, that means their inclinations are same, their slopes are equal. So, you know, whatever you have learned previously, just keep on revising that as well according to the further concepts. So, if I draw two lines as parallel lines, what is the angle between them? Angle between them means what is the angle that is being formed between these two lines. Now, obviously because these two lines are not at all intersecting, the angle between L1 and L2 is 0. So, angle between L1 and L2 is equal to 0 as L1 is parallel to L2. But other case, if I consider the scenario, you know, something like this. Say this is line 1, this is line 2, say L1 and this is L2. In this situation, the two lines are definitely not parallel and they are intersecting at a single point. In here, say this is theta 2, this is theta 1, respective inclinations of the two lines L1 and L2. What is the angle between these two lines? Now, there are two types of angles between two lines. Whenever two lines intersect, they produce two pairs of vertically opposite angles. One is this pair. Basically, these two angles will be same, vertically opposite. You can see these two are acute angles right now according to the picture, and they both are same. I am saying, say this is angle theta, this is also theta. Another pair of vertically opposite angles is this and this. These two will be equal. You can see and judge that there will be obtuse angles, ekdam equal, same in magnitude. Now, in here I can say this is xi, this is also xi. What happens is whenever two lines intersect, they produce two pairs of vertically opposite angles. One is this, other is this. So, if somebody asks you, what is the acute angle between line L1 and L2? You will say theta is the acute angle between line L1 and L2. When somebody asks you what is the obtuse angle between line L1 and L2, you will say xi is the obtuse angle between line L1 and L2. And the beauty of these two vertically opposite angles, theta and xi, these two pairs of vertically opposite angles, is that theta plus xi is equal to 180 degrees. You can see that they both are actually supplementary angles. When you add them, you get 180. Either you add these two, or you add these two, or these two, or these two. In any case, theta plus xi is 180. So, in here, acute angle between L1 and L2 is theta, an obtuse angle between L1 and L2 is xi, but this xi can be found out only when you are aware about the acute angle between L1 and L2 only. Why? If you are aware about theta, you know that theta plus xi is 180. Just from 180, you remove theta, you get the value of xi. That means if I only learn to compute the acute angle between two lines, in that situation, I can definitely also draw the very value of the obtuse angle between those two lines by just removing the acute angle from pi, isn't it? So, my entire concentration from now on would be to understand how to draw information about the acute angle between two lines which are intersecting, because if they are not intersecting, angle is 0, there is no point of discussion over the angle drawn between the two lines. But if they are intersecting, then I need to compute the angle which is there between these two lines, and that too primarily focusing upon acute angle. Is it understood? Acute angle between two lines L1 and L2 is our topic of understanding. The moment this is understood, understanding how to compute the obtuse angle is a cakewalk, because I will just remove the quantity of acute angle from pi and I will get the obtuse angle. So, let us consider the scenario when we have two intersecting lines and our primary aim is to compute the acute angle between those two intersecting lines in terms of, with the help of slopes of those two lines. Yes, at the end of the day, what we are doing is understanding the application of slope. First application was to judge whether two lines are parallel or perpendicular depending upon the nature of their slopes. Next application is finding the angle between two lines with the help of the slopes of those two lines. I am saying let L1 and L2 be two intersecting and non-vertical lines. Why non-vertical lines? Because otherwise their slopes will be not defined, and whenever the slopes of lines are not defined, it just kills my discussion ahead. I cannot talk about those lines any further. I need full-fledged slopes to be present of both the lines. Therefore, I am focusing upon lines being non-vertical. Let L1 and L2 be two intersecting and non-vertical lines, and M1 be equal to slope of L1 and M2 is equal to slope of L2. As they are non-vertical lines, M1, as they are non-vertical lines, M1 and M2 are actually real numbers. It's not like they are not defined, they are actual real numbers, either positive or negative. Also, if L1 is perpendicular to L2, then angle between L1 and L2 is equal to 90 degrees, isn't it? If L1 is perpendicular to L2, suppose this situation occurs, something like this, that say one is this line, other is this line, this is L1 and this is L2, and you can see that they are perpendicular to each other. In this case, the angle between the two lines will be 90 degrees, right? Angle between L1 and L2 will be 90 degrees. And you know that if two lines are perpendicular, product of their slopes is -1. So, this is also going to hold. So, this is the scenario about, or in which I can conclude about the angle between the two lines. But what if the two lines are not perpendicular? What if the two lines are not perpendicular? See, if the two lines are perpendicular, then angle between them is 90. Or if the two lines are perpendicular, because you have seen that M1 into M2 is -1, you can conclude two lines are perpendicular, and so the angle between them is 90 degrees, right? Both the pairs of vertically opposite angles will be 90 only, right? But if L1 is not perpendicular to L2, then if L1 is not perpendicular to L2 and L1 and L2 are intersecting at a point, then what is going to happen? Then the scenario is going to be something like this. The two lines are not perpendicular, but they are intersecting. So your scenario will be something like this. Say this is L1, say this is L2. So you have actually got your two lines L1 and L2 wherein they are not perpendicular and they are intersecting at a point. You can see I am going to name this as theta. Okay, this I will be naming as theta. This is one pair of vertically opposite angles which is produced when the two lines are intersecting, and I will be naming this angle, that is obtuse angle, as xi. I am saying this is alpha 1 and this is alpha 2. Let me tell you what all this is. Alpha 1 is the inclination. Alpha 1 is the inclination of line 1. Alpha 2 is the inclination of line 2. This implies tan alpha 1 is m1, that is slope of line 1, and tan alpha 2 is m2, that is slope of line 2. The moment I am saying L1 and L2 are not perpendicular, clearly m1 into m2 is not equal to minus 1. If it would have been equal to minus 1, then the two lines would be perpendicular, because this is an if and only if condition. If they are perpendicular, angle between them is 90 degrees. If they are not perpendicular, that means angle between them is definitely not 90 degrees. But what is it? We need to conclude about that. So in here, one thing is sure, that the product of their slopes is definitely not equal to minus 1. Okay, this much is understood. Next we have theta and xi. Theta is acute angle, or rather than that, let us just, because this is not the case which is always going to occur, so let us just start proving first, then we will draw the conclusions about theta and xi. Fine? We need to compute theta and xi. So clearly, xi plus theta is 180. Theta is the acute angle between L1 and L2. Xi is the obtuse angle between L1 and L2. Theta plus xi definitely a supplementary angle. So theta plus xi is 180. Therefore, xi is pi minus theta. Right? Xi is pi minus theta. Now please understand, this is going to be useful later. If I talk about exterior angle property, I can see that alpha 1 is equals to alpha 2 plus theta. Alpha 1 is equal to alpha 2 plus theta. Right? This means alpha 1 minus alpha 2 is equal to theta. Alpha 1 minus alpha 2 is equal to theta. If alpha 1 is alpha 2 plus theta, this is line 1, so this is alpha 1, this is line 2, so this is alpha 2. I am saying alpha 1 is alpha 2 plus theta, that means this is the case. So tan theta is equals to tan of alpha 1 minus alpha 2. Tan of A minus B is what? What is tan of A minus B? It is tan A minus tan B upon 1 plus tan A tan B. Tan A minus tan B upon 1 plus tan A tan B, isn't it? Tan theta is tan of alpha 1 minus alpha 2, tan of A minus B is tan A minus tan B upon 1 plus tan A tan B. What is tan alpha 1? It is m1 minus m2 upon 1 plus m1 m2, right? Tan theta is coming out to be m1 minus m2 upon 1 plus m1 m2. This implies tan theta is m1 minus m2 upon 1 plus m1 m2. What is this? This is the very formula to give you the value of theta with the help of slopes of the two lines. If you have the two lines with slopes m1 and m2 such that m1 into m2 is not equal to minus 1, if m1 into m2 is not equal to minus 1, 1 plus m1 m2 is not equal to 0. If m1 into m2 is not equal to minus 1, then 1 plus m1 m2 is not equal to 0. That means denominator is not equal to 0. That means this quantity that you can see is a proper real number. That means theta is going to come out to be an acute angle or an obtuse angle. If this is a positive real number, m1 minus m2 upon 1 plus m1 m2, if this is a positive real number, theta will be coming out to be an angle from 0 to 90. And if this is a negative real number, theta will be coming out to be an obtuse angle from 90 to 180. So depending upon this is positive or negative real number, theta is going to come out to be acute or obtuse angle, isn't it? But one thing is sure, that this thing is never ever going to be not defined, because the denominator is not equal to 0 for sure, because we are in the situation when m1 into m2 is not equal to minus 1, because L1 is not perpendicular to L2. Clear? Now in here, if you consider this nicely, this equation is going to give you theta. If you have tan theta equals a real number, that is going to give you the value of theta from 0 to 180, where theta is one of the angles between L1 and L2. If you have theta with you, how can you compute the next angle between L1 and L2? Also, as xi is pi minus theta, how to compute xi? Tan xi is tan of pi minus theta. Tan of pi minus theta is minus tan theta. Minus tan theta means minus of m1 minus m2 upon 1 plus m1 m2. This is tan xi. Tan xi is minus of m1 minus m2 upon 1 plus m1 m2. Clearly in here as well, 1 plus m1 m2 is not equal to 0. 1 plus m1 m2 is not equal to 0, because m1 into m2 is not equal to minus 1. Now in here what is going to happen is, again because denominator is not equal to 0, m1 minus m2 upon 1 plus m1 m2 with a minus sign, this complete thing is going to be a real number. If this is positive, xi is acute. If this is negative, xi is obtuse. Now please understand the relationship between tan theta and tan xi. If theta, according to the diagram, theta is acute angle, then xi is obtuse angle. So are we getting that by the formulas as well? If according to the diagram, theta is acute, that means m1 minus m2 upon 1 plus m1 m2 will be a positive real number. If this is coming out to be a positive real number, clearly its negative is going to be a negative real number. So minus of m1 minus m2 upon 1 plus m1 m2 will be a negative real number, implying that xi will be automatically obtuse. And if we go by the next scenario, wherein suppose the name of this angle would have been xi, the name of this angle would have been theta, for example, then in that case m1 minus m2 upon 1 plus m1 m2, if it comes out to be negative, then theta would be obtuse. If this quantity is negative, minus of it will be positive. So this is positive, that means xi is acute. So if theta is coming out to be acute, xi is coming out to be obtuse. If theta is coming out to be obtuse, xi is coming out to be acute. Is it clear? This is what is happening in this case of theta and xi. Quickly note this down, and then we are going to draw certain very nice conclusions related to theta and xi. Now, before I talk about certain cases which can arise, which I just discussed about theta being acute, then xi being obtuse, or theta being obtuse, then xi being acute, one thing I would like to discuss, if you would have taken this as L1, its inclination here would be alpha 1, this would be L2, here inclination would be alpha 2. In that case, I would have written alpha 2 equals alpha 1 plus theta. alpha 2 equals alpha 1 plus theta, in which case I would have got alpha 2 minus alpha 1 is theta, and the formula would be tan of alpha 2 minus alpha 1, tan alpha 2 minus tan alpha 1 upon 1 plus tan alpha 2 tan alpha 1, which would have given me m2 minus m1 upon 1 plus m1 m2. So I would have got over here m2 minus m1 upon 1 plus m1 m2, and here it would be minus of m2 minus m1 upon 1 plus m1 m2. So whether you get m1 minus m2 or m2 minus m1, situation is going to be the same, no problem, because the end conclusion which we will be deriving right at the end of this article would be of major importance. So keep these two formulas in mind. Let's talk about the cases which arise. In this article, angle between two lines, we have two cases thus arising. Thus, two cases arise. Let's understand. Case 1. If m1 minus m2 upon 1 plus m1 m2 is positive, suppose this real number, because 1 plus m1 m2 is definitely not equal to 0, this is a real number. If this is positive, that means theta is acute, right? If this is positive, then theta is acute. Theta is acute. If this is positive, then minus of this will be negative. Also then, minus of m1 minus m2 upon 1 plus m1 m2 is negative, which implies xi is obtuse. Okay, so if this quantity comes out to be positive, theta is the acute angle between L1 and L2, and in that case xi will be obtuse angle between L1 and L2. Case 2. If m1 minus m2 upon 1 plus m1 m2 is negative, suppose it comes out to be a negative real number, this implies tan theta is negative and theta is the angle which is going to lie from 0 to 180 only. So theta is going to be obtuse, and then if this quantity is negative, minus of it is going to be positive, which implies, what is minus of it? It is tan xi. Tan xi is positive, that means xi is acute. Basically, if you can understand very nicely, the moment I am going to get m1 minus m2 upon 1 plus m1 m2 as positive, I am going to get this angle to be acute. And if I get acute angle between two lines, by removing that angle from pi, I will be getting obtuse angle between the same two lines. So my actual conclusion about angle between two lines is now going to be declared to you as the final statement. Thus, see, please understand one thing, what is it that is making an angle acute or obtuse? This quantity is not changing. If suppose this is 3, m1 minus m2 upon 1 plus m1 m2 comes out to be 3, for example, this is minus 3. So magnitude of 3 and minus 3 is the same. The only difference is of the sign, one is positive 3, one is minus 3. So by the magnitude wise if you see, mod wise, absolute value if you see, it is 3 only. That 3 is actually deciding factor, not the sign. And therefore my final conclusion is going to be about the actual magnitude of the number m1 minus m2 upon 1 plus m1 m2 independent of the sign. I will be saying thus, the acute angle between two lines, obviously they are non-perpendicular, they are not perpendicular to each other, which implies that m1 into m2 is not equal to minus 1, and they are non-vertical. None of them is vertical. so that the slopes are defined. Acute angle between two lines L1 and L2 with slopes M1 and M2 is given by tan theta equals mod of M1 minus M2 upon 1 plus M1 M2. Why mod? First of all, please write 1 plus M1 M2 is not equal to 0, so that it is ensured that denominator is not equal to 0, and therefore this is a real quantity. See, why am I saying this theta is definitely going to be acute, and this formula is going to give you acute angle between L1 and L2. This theta is the acute angle between L1 and L2, which you will be able to find by this formula. First compute this value, and the theta between 0 and pi at which this value is being obtained is the acute angle between L1 and L2. Why am I so sure this is acute angle? Because if M1 minus M2 upon 1 plus M1 M2 comes out to be positive real number, then mod of it will be the same real number, which is positive. Already positive, mod of a positive number is that number itself. And tan theta, if it is positive, that means theta is acute. Next, if M1 minus M2 upon 1 plus M1 M2 comes out to be a negative real number, then mod of a negative real number is the same number with a positive sign. Magnitude doesn't change, just the sign changes. So if this is negative, mod of it is positive. That means tan theta is again coming out to be positive. So again theta is acute. So this formula is giving me acute angle between L1 and L2, and the obtuse angle xi between L1 and L2 can be obtained as, how can you obtain xi if you already have got theta? If theta is the acute angle between L1 and L2, the only thing which I know about acute and obtuse angle between two lines is that when you add them you get 180. So when you add acute angle plus obtuse angle between two lines, you get 180. So obtuse angle is nothing but 180 minus acute angle. So xi will be equal to 180 minus theta. Is it understood? The only and only task of yours would be that you will be given two lines. If they are perpendicular, angle between them is 90 degrees, end of the story. If they are not intersecting, angle between them is 0, end of the story. If they are vertical, then slopes are not defined, end of the story. But if they are intersecting, non-vertical, non-perpendicular lines L1 and L2 with proper slopes M1 and M2 such that you are getting M1 into M2 is not equal to -1 because they are not perpendicular. In that situation, if you need to find the angle between those two lines L1 and L2, full-fledgedly you just need to compute M1 minus M2 upon 1 plus M1 M2 and take its absolute sign. That particular value is equal to tan theta, where theta is going to be the acute angle between L1 and L2. Once you have computed theta, remove it from pi, get the obtuse angle between L1 and L2. Is it understood? So this happens to be the entire concept related to angle between the two lines L1 and L2. Is it understood? Please get this very, very clear. If you are given the slopes of the two lines and you need to compute the angle, compute absolute value of M1 minus M2 upon 1 plus M1 M2, absolute value, right? Depending upon that, conclude about the acute angle, and using this conclude about the obtuse angle. There is no need for you to get confused among these two things, that calculating its sign, then declaring which angle would be acute and which angle would be obtuse, then again calculating its sign if it comes out to be negative, then which one is acute, which one is obtuse, because they are switching. Here theta is acute, xi is obtuse, here theta is obtuse, xi is acute. So we fix theta for acute angle. We fix theta to represent the acute angle between L1 and L2, and that theta is fixed to represent the acute angle between L1 and L2 on the basis of this formula. On the basis of this formula, theta is fixed to represent the acute angle between L1 and L2, and xi is fixed to represent the obtuse angle between L1 and L2. Is it clear? We will be watching out some more stuff related to slope and also different equations of straight line in the next lecture. That's it from my side. Thank you.